Hey guys, I'm back again with another live stream. Uh, today, today things are a little different. Okay, so what I thought from past 1 week was how to improve upon things which, for specifically for improving our interviews preparation or something like that. Because I got some few DMs in me like preparation or solving questions randomly is not going to give me everything what we want. So basically what I thought of preparing something from specific for specific. So I got somehow I got to know that Google has the one of the best DSA preparations. We already know that, obviously, so I don't have to tell you anything about that. So but we know that Google has the best preparation, and if we are prepared for Google interviews enough, then we know that we will be able to solve Microsoft questions, even Amazon, Meta, Apple. So they do ask very similar questions like Google, but the bar of Google is a little higher than anyone else. So what I thought of, let's start preparing for Google interviews. Let's try our best to give our best to solve all the questions or cover all the varieties. So yesterday I was looking into a video on YouTube where I got to know about Faraz. Actually, I already know him. I'm a big fan of him. He has been doing these good stuffs from past I don't know how many years, but it's really good. So I thought, why not go for Faraz preparation? What he did, how he did, was really amazing, and he covered all the varieties, all the things in one go, and he created it systematically in GitHub. In GitHub. So today I'm thinking of not going directly with solving questions randomly or taking time to. We'll cover all the important topics. Even we if we don't know how to write those code or logics or something, we'll watch YouTube videos, everything whatever we can, but we will try to understand everything and try to solve it in a better way, in a better approach. So if any one of you are preparing for Google interviews, you can get the insights or things which might which we might miss. So this is how I'm thinking of going for the yeah, for this live stream. uh, so I'm thinking of like specifically preparing for a Google interview. So I'll be going uh, more hard and more continuous way. So I think I'll be doing live stream tomorrow also, uh, and 2 weeks, 2 days in a week, Saturday, Sunday, and in between I'll try to cover more of the topics which I will discuss in Saturday and Sunday discussion. So I'll get revision also, and you'll get to know everything. And if I get any more insights, I'll surely add it to it in the live stream. And also I'll try to create notes by myself. Let's see how it goes. So this is how what I thinking. So let's try our best, and let's see how things are flowing. Okay, so starting with start, I'll be picking up graph, then I'll go over dynamic programming, then segmentary, then rolling hash, and for the rest of the topics, I don't know, he removed it or something like that. Okay, okay. For the rest of the topic, he referred to the his DSA sheet. So that's fine enough. So we'll cover rest of the topics with our DSA sheet, with his DSA sheet. Of course, he has a good DSA sheet. I don't know. He has a link. Okay, YouTube link. Where is this DSA sheet? Yeah. So this is its DSA sheet. So I'll try to cover as best as possible, as much as I can. There are lots of people looking at these sheets today. Okay, so first we'll go with graph. Let's try to understand, and if we don't understand, we'll watch YouTube videos also. So how to write? So I'll pick my Sublime text. I need some sidebar, show open files. Yes. So this is in group 1, group 2 and group 3. Okay. So any way to create a folder here? I remove this. If I can I create new file? We can only create new file. I don't think we will be able to create new folder. Fine. We'll sort it afterwards. So let's start with some prefix graph representation. We'll go little slow, will not rush. We'll understand each and everything. We'll understand the concepts, everything, and then we'll move to next question. Next thing. So first I'm thinking of understanding the concepts, everything, and then we can pick the questions, and then we can solve the questions. So let's try to understand the graph representation, how graph goes, flows with list and matrices, and then we can go to its implementation, even the space and time complexities. So this is graph representation list. Okay, so we can do one thing. I am not coding it or not running it, so what I can do is I can create a folder. Maybe I'll name it Google Prep. Open it. I'll create another folder which is graph representation and inside I'll save this as list .cpp. Fine enough. So I have some defaults which I usually don't want in this, but still I'll take it. So we need to represent a graph in list. So we know a graph. Whenever we talk about a graph, where is my let's try by ourselves, and then we can uh, see what I remember from um, list or graph that will be given edges. It's the basic thing that we get in a graph is the source node and the target node, from where to where it is connected. So from source to target, this will be a list of source and target, list of list, something like that. It will go something like that. So we need to create a graph for this. First of all, we need to know how many nodes are there, total number of nodes, what is the maximum value that a node attains. If we know uh, the maximum value that a node can attain, we can create a 2D array of that many size. Like suppose if n value is 5, that means we have nodes from 0, 1, 2, 3, 4 and 5. If something like that this happens, we know that we can create a 2D array of size 5, 0, 1, 2, 3, 4, and for every index will push the values which it connects to. So 0 connects to 1, 0 connects to 2, 0 connects to 3, uh, wherever it connects. So 0 is connected with 1, connected with 2, 2 is connected with 3, something like that. So 0 is connected with 1, 0 is connected with 2, 0 is connected with 3, even 2 is connected with 3. So something like that we create our uh, graph representation. But if we don't have the size given, in that case we can use map, unordered map, which in which key value will be integer and the value will be a vector of integer. This will do what? This will not bind us in a fixed size of 2D array. This will give me random. If we have random source and target, even if we have target values like 1, 2, 3, 4, and one node is 10,000 values, so we are not creating a 10,000 values 2D because we only need 5. So in that case we even go for map. So maps are way better, but still maps has some limitations that it cannot go more beyond a specific value, beyond something. So maps have certain limitations. So for graph, for list, what we have is if we are given vector and edges is nothing but list of 0 connected with 1, 0 connected with 2, 1 connected with 2, 2 connected with 3, something like that. So the default representation will be, if we are given n as 3 for now. So what we'll do is we'll create a graph. This graph will have n size, and second half will be empty because we don't know how many nodes are there. So this way we'll represent. Now pushing into I is lesser than edges dot size plus plus I, or this graph will contain source is nothing but edges of I of 0, target is nothing but edges of I of 1. So this graph dot graph of source dot push back my target. So this will create my graph. So this will create a unidirectional graph. If we want something, some graphs are bidirectional also, so we can even create target or source. So this is something how we represent a graph in list form and not in matrix form. Correct. Okay, so in list form, this is the way we will represent it. Now representing it in is there anything that we are missing over here? Now rest of the part is how to solve this graph, but representation is something like this. Possibly, right? Is there anything that we are missing? Maybe, maybe not. Let's try to check. Let's try to check. Okay, so int n is 6. We have edges something like this. It always goes like this. So we created a map. We can even create an unordered map, or we can go for direct values. It doesn't matter. Unordered map also is not an issue. Map is also not an issue. So we found A and B. So edges graph A dot push B. So this is a unidirectional if there is an direction. If this is bidirectional, we will need to push graph B pushback dot A. So that also can be done. मैप छोड़ो जिंदगी बनाओ. Yes bro, जिंदगी बना रहा हूँ. If you want also to crack Google interviews, be with me na. So this is how we print. Okay, printing part is fine enough. We will print it. So source, I need to print the source. So I is nothing but source. This I contains how many values? Not G, graph of I dot size plus plus I graph of I of J with some space, and after that we need and L. this is my target, or yeah, we can say that. So this is how we will print. We may declare it. One way to declare. The other way to declare is also we can use unordered map of int comma vector int. Graph. And in this case we don't need any size or anything. Another way to. I know that I saw the notification, but I'm not going to see it now. This is my focus time, okay? After 38 minutes, I'll have to it. So this is how we represent a graph in a normal list format. Now, after this, we need a matrix format also. So this is how we represent it in list format. Now we need a matrix format. So let's create another tab. Matrix.cpp. What, you found something interesting? Tell me. I'm also interested. If it is related to data structures and algorithm, and if not, then do not. What about your stream, bro? Where is your stream? I don't see your stream regularly. You're not regular, huh? It's related to the live stream. No, not related to live stream. No, related to DSA. I want. So we need to represent it in matrix format. So now, how we can represent it in matrix format? It's very much look alike. It very look alike like the list. In list we specifically have values. We don't use extra spaces, but in matrix format we will be using some extra space. So we will be creating some n cross n matrix, and we will be inserting some values in n cross n matrix, right? From what I remember, because I haven't practiced matrix format of graph for a long time, so I need to look at it once. But what I remember from my thing is, if we have these kind of source and target, we need to 0 is connected with 1, so we will be creating 0 1 2 3 4 n cross n matrix, and after that it's related to it should be related to DSA. I'm on a break testing the YouTube algorithm. I'm getting views watching passively. No, bro, you are testing the YouTube algorithms. I don't think YouTube will give you anything for that. If you want to test it, test yourself, not YouTube algorithms. You're wasting your time, bro. Just do the live stream. Simple as that. Passive earning is nothing. It's a joke. So 0 is, if 0 is not connected, 0 is directly connected with 3. So 0 is connected with 3. So maybe we can even represent it with 0 1 0 1 0 1 values, because we do not want anything. So everything will be initially 0. 0 is connected with 1, so it will contain 1. 0 is connected with 3, this will also contain 1. And rest of the places we can place it, place 0 for now. So 1 is connected with suppose 1 is 1 is connected with 4. So 1 is connected with 4. I think I'll place 1 over here. So it goes something like that. N cross N matrix. And trust me, kids are watching Palworld and Plasmophobia daily. I'm getting good watch time. Bro, but you should grow your channel. You should not stop your channel growth. Okay, passive is fine, but you need to be active to increase your passive, something like that. So you are not, I think. Three is connected with one. We'll place one over here. So it's something like that. I think it's something like that. So let's not waste time more on this. Let's directly look into the code how matrices we use. So we do create n cross n matrix for this, and mem we are setting it to 0 for the size of the matrix, and we are initializing all the values to 0. What I did, initializing everything to 0, and then we are placing 1 over it. Correct. So all the way, all long, I was totally right, but I was not confident enough that this is exactly the way it should be. So I did 300 live streams in 6 months. Let me have a break. No, bro. Break is just a word. It's not anything. You have already taken a lot of break. You went to Rishikesh. You did bungee jumping and river rafting and all. That's something called a break. It's you are doing a 4 in a month. Exactly, but I'm consistent, huh? I'm doing the whole year, and not like you doing 6 months and the rest of the 6 month you're on break. It's not something like that. So I'm continuous. I'm doing it for the whole year. Straightforward. So matrix representation is not difficult. I'll just copy these things. I don't want to write these again. For this we may create matrix of n comma n size, and will iterate we need to first do the memset part. Even we can declare it using vector. That is also not an issue. So we are setting up the memory int memset matrix of initialize it with 0 size of. I'm happy with my life. Bro, you don't want growth. Why you bought RTX 4090, bro? If you want growth, you need to work on yourself, huh? You need to work on your YouTube channel. You need to work somehow else. Your all money, all savings will be gone one day. So now my matrix of I of no right int a edges of I of 0, int b is edges of I of 1. Now matrix of a b is equals to 1. This is how we'll represent, and for printing we'll just directly now you are talking like network marketing people. No, I'm not talking about network marketing people. I'm talking about life. what you told me. You are happy with your life. I found that is okay, but I think growth is more important than being happy. Happy is one part of your life, and growth is another part. If you are whatever you have in your current bank account, if that is okay to you, I don't have any problem. But if you want to grow, do it. Do the live stream, bro. So we print the source as I. I will always be my source, and my target will be nothing. If matrix of I j is equals 1, uh, I'll print j, that source and target is connected. Great. Give me a minute. I'll be back in a minute. I'm getting a call. Just a minute. I'll be back. Oh, I'm sorry. My mic was off. Really sorry. Is it audible now? Really sorry. Actually, I clicked on it, but somehow it didn't. Can you cross check? Is it audible now? Death. I told a lot of things about this BFS, breadth first search. Good. Thank you. Thanks a lot. Okay. So what I was saying that in breadth first search we need to handle one thing, that if we are going from 0 to 1, we should not go from 1 back to 0. So for that we need something uh, which will track that okay, this node was visited, I should not go back to this node again, because if we go back to this node again, we'll get stuck in loop from 0 to 1, 1 to 0, 0 to 1, 1 to 0. So we don't want that. So for that we kept a visited array. Whatever node will be visiting, will be marking it in any way. Why are you laughing? Is this a funny live stream? I don't think I'm creating any fun over here. It's serious. Okay, fine. So while queue is not empty, will be this is my current node, q dot top, q dot pop will pop this. So we know that we visited 0. So in my visited array, I'll make current node as visited. Now I need to visit all its child, and I need to make sure that all of its child are not visited. Right? It was funny for a while. I know that. No audio, and still I'm doing blah blah blah. It will always be funny. I don't laugh, huh? Thank you for telling me. Graph of current node dot size plus plus I. So I have a new node which is graph of I of, sorry, graph of current node of I. So this is my new node, and this new node should not be in my visited list. So if visited of this new node is equals to 0, that means this is a new node that I haven't visited. So I'll push it in my queue, queue dot push new node. And I already popped it here. Queue is not empty, it's fine. Yeah, I think we are good with BFS. Is there anything that I am missing in this BFS? It's not that difficult, but I think this is a proper format that uh, we should follow. Let's see if if we are correct or we are wrong. Sorry, valid BFS. Oh my god. What he commented here, we can sort the uh, adjacency list according to the given sequence and generate a BFS and then compare. There is something that he added extra because from here what I can see, we have adjacency list. This is my ADJ list. We have these edges we created. I should name it adjacency list. I should name it because making it as a graph is not making any sense. It should be adjacency list, and wherever I sorry, in graph I should make it adjacency list. Well, naming doesn't matter, but it will matter if you are solving any complex question. So it's always better to write a name which you know and which is a better convention to follow. So adjacency list, adjacency matrix is a better way to represent a name of a graph. So it's always good. So he created a adjacency list where he pushed. It's a bidirectional. What I handled, he he created a visited correct of n plus 1 size of value 0. He created a queue. He pushed 1 to it because this is the starting position that we want. He created a resultant node. Okay, we need a resultant node. That's fine. Okay, so what is the sequence? Where is the sequence? He did created something, no? Which is something or the other, a unique way. Not unique way. I need to understand what he wants to do, because the rest of the thing is fine. Visited is fine. He created auto a. He popped the front. He took the front value. He popped it. In result, he push back that value. That's fine. That. Oh, okay. Uh, these all. This is a valid BFS. If it is visited, if it is not visited, I'm pushing it in queue and marking it as visited. He's not marking it here, he's marking it here. That's fine. I can do it even here also, even here also. It's not an issue. Valid BFS, is it a lead code question? BFS and its variation. Okay, let's look at it. Let's try to find anything which is different than a normal standard BFS. Standard BFS from borders. Okay, there is two things. One is standard BFS, 0, 1 BFS, multi-source BFS, BFS with bit masking state, and a bidirectional BFS. So there are 1, 2, 3, 4, 5, 5 variations of BFS, correct? Check if there is a valid path. Okay, okay. And these are some of the BFS questions. Fine enough. Bro, it's not BTS, huh? If you'll stay on the stream, not going back and coming and going back and coming, then you'll get to know what I'm talking about. And if you are not staying on the stream, you'll never get it, bro. This is not playing games. This is something serious that I'm talking about, huh? Okay, let's talk about its variation. Let's not deviate from our path. So we have a standard BFS. This is pretty standard. We use a queue, add an explode node at each level until queue is empty. Why BFS always found shortest path? So BFS will always give us the shortest path. It's not related to stream. It's related to data structures and algorithms. I think Death knows better than you, because that's why he is quiet and he is studying whatever I am saying. Not like you. Bro, get real, huh? The very first time a node is discovered, the unvisited node, its distance from root node will always be shortest. For example, we have a root and it has 3 neighbors root. Okay, fine. This is the shortest path. For this we need a priority queue. That is not a problem here. Death is also enjoying the content. Yeah, that is what I'm saying. If you will put content like this, anyone can have anyone can be deviated from its path. No, should not be doing this. Okay, let's see what I followed in this. I did a DFS. Okay. Do we have editorial? No. Oh, I do have my solution also placed. And 172 views. Oh my god, wow. DFS, BFS, TSU, standard algorithm, Python, Java, C++. Oh my god. I need BFS. Yes. I need to know. Okay. So this is a standard way to follow. Visited, if it is not visited, add it in visited and add it in queue also. So maybe I'll follow this only. Instead of visiting it over here, just pop it out. If it is not visited, make it visited. And so for that I need to keep my visited of start as 1, because this is already visited, and then we can start from here. Yes, we placed our visited in source. See, I need C++. I've inserted in my visited array, and if it is not visited, I'm inserting into my visited and I'm pushing it in my queue also. Hungry? No, bro. I've taken uh, 3 breads and 2 omelette, so I'm full. So BFS is good. I think I should be following this. I need to know what he did. What is this? What is this? Exactly that. Exactly. That is what I'm. But just add, remove that sir from last. If you can edit that. My name is fine enough. Now it looks fine. Saurav, you will always be on top. Hey, I don't know if he talks with me like this or not. That I don't care about. But I'm pretty much sure that he talks with you like this only. The way he said that bad seed. So I know that is true. I don't know about Kundan sir, but bad seed I know. That is totally true. So we are given edges, we have adjacency list. Why we are creating a sequence? What this? Is there? So it is saying that we have a sequence. Okay, this sequence is. I'm not getting it exactly, the sequence part. we have something, some sequence. I want a graph to be in this sequence: 0, then 2, then 1, then 4, then 5, and something like this. So I reordered it. I sorted the edges, reorder based on if they are equal. Reorder A of 1 is lesser than reorder B of 1. This is something I need to look into. What is exactly this, and what are we doing it here? Reordering part, because I'm not getting any context of it. That is the reason I'm not able to understand it properly. If I get a context and how it is done, then I can understand it in a better way. But for now, I think this is not bad. We can also have excuse me, vector int array, result, maybe result. I'll make it as a result, and every time I'll push it in my result dot push current node. Yes, bro. 4 are watching me live and no one is doing like, bro. Please do like. Thank you, Death. I think now Saur will get the insights of how I am is. Okay, so this is a valid BFS. Not a problem. Totally fine. I'll look into this. I'll look into this sequence. I'm not understanding the exact thing why sequence is added, but I'll look into it once. Hey, do not do that. Do not do that. Do not click again. That's why Gaurav added that thing, no? Multi-source BFS. What is a multi-source BFS? Multi-source, the word says that we have multiple sources from where everything is getting started. This is a really good use case of multi-source BFS. In this question, we see how we can traverse from a point to that point itself using minimum path. We can go back and forth between nodes, but should never land on the same config again. Okay, shortest path visiting all nodes. This is a lead code 847 question. No, bro, I don't want 2 likes. I want 2 likes, but every like should be from different account. So use your different account and do the like. I know you have an account with a girl name, so do like from that also. There also. So what in this? Map. We have been given a graph. Let's open this question. Shortest path visiting all nodes. If this is a multi-source BFS, let's understand what multi-source BFS is. Ah, bro, you are hiding all those things, huh? For someone special, I know that. Girls account and all those things. I'm getting it. I'm getting it. You have a undirected connected graph of n nodes labeled from 0 to n minus 1. You are given an array graph. We are given an array graph. Graph I is the list of all the nodes connected with node I by an edge. Return the length of the shortest path that visits every node. You may start and stop at any node. You may revisit node multiple times and you may reuse edges. Okay, this is something good. I would say this is something really good. So this question says that I need to find a shortest path. I'm not sure if I solved this question. Yes, I did, but I tried with something else. I had tried it. Time limit exceeded. Fine, I will. So this is something multi-source BFS, right? Let's see what's. Hey, bro, don't go now. I need you to stay here for 10 hours continuous so that I can get what should I say? I can get what that word is. Monetization. I need monetization. So I need you. Okay. So I need to visit all the nodes. I need to find the shortest path that visits every node. You may start and stop at any node. You may revisit nodes multiple times and you may reuse edges. So if I start from 0, I can go to 1. From 1, I can go to 2, I can go to 3, but to go to 4, I'll have to go back and then go to 4. So this will take, I think, from 0 to 1, 1, from here to here 2, from here to here 3, going back 4, and here 5. But we can even visit every other node in 4 steps only. What the step says, it's go to 0 to 1, from 1 to then 4, from 4 to 2, and then 2 to 3. So this way I will be able to revisit. So what I can see, or what I can say is I need to start from every node. let's not look at this solution. I think this solution fails. This solution gives time limit exceeded. Yes. Yes. So I should not look at this. What I can think of is, let's push all the nodes in the queue and start from every node and go to every other node. But every time, every node will have a visited part. So this is how multi-source BFS can take part in this. Mm-hmm. What is exactly multi-source BFS? Let's read it from here. Multi-source BFS. Okay, this is 0 1. This is the main difference. These all are rotting oranges. Map of highest peak as far from land as possible. Walls and gates are premium. What is multi-source BFS? Let's understand it. Generally, we start BFS with a single source node and then traverse. In this class of problem, we are given multiple source. Generally, we start BFS with single source node and then traverse. In this class of problem, we are given multiple sources. So we have multiple sources. How example multiple now target location are there. Now example multiple target locations are there, and you have to find nearest target location from each node. For example, multiple target location are there. Fine. Multiple target location. You have to find nearest target location from each node. Okay. From each node, which is the nearest target location that we need to find. Real life example is multiple cities, and some has police station. For each city, find nearest. Real life example is multiple cities and some has police station. Correct. Oh, okay. For each city, find the nearest police station. So in these kind of problem, put all the source node, some time destination node, and then start the Okay, we need to put all the sources. This is multi-source BFS. We need to put all the source node at once and then start the BFS. The moment we find a city from police station, we know that's nearest surely. Okay, so these kind of problem, sometime we need to put all source node, or sometime we need to put all destination node. So in this case, where we need to find the nearest, we will be putting all the police stations in my uh, source, and from there we'll start to traverse. So then we'll get to know which is nearest. Okay, so it's not that difficult, I would say. Multi-source BFS is fine enough uh, to solve. It's just uh, we need to handle few things. Simple BFS is directly starting from a specific node. Multi-source BFS is something starting from multiple nodes and going to multiple nodes. So, fine enough. Okay, so we'll be solving this multi-source BFS problem uh, with an example. This is shortest path visiting all nodes. We'll use this example, we'll try to solve it, and after a short break, I'll be back in 10 minutes. Don't go anywhere. After when I'll be back, we'll start solving this question. And we will understand each and every concept, how it is working, and then we'll move forward. And then we'll go for DFS, and there are a lot of things we need to cover. So we need to be quick, fast enough. So I'll be back in 10 minutes. Don't go anywhere. Back. See you. Hello guys, I'm back. I'm back. Let's go. So, uh, we got to know what is multi-source BFS. Multi-source BFS is nothing but a little variation in normal BFS. Normal BFS we generally start from one node and we explore all the other node. But in multi-source BFS we generally start from we start from multiple nodes and we explore the other nodes whatever our target is. So we have multiple source node, multiple target nodes. So based on the question or based on the condition, we might put all the source node in one and or all the target nodes in one BFS queue, and then start from there and go to all the other node, visit all the other node until and unless we reach the target node. So for example, there was given if there are multiple cities and there are few police station, like possibly there is a police station in one city and might not be a police station in other city. So we need to find uh, all the shortest police station or the minimum distance every city has to its nearest police station. So we can keep all the police station here in our queue, and from all the police station we can explore all the cities. We can go to all the cities and find the minimum distance whosoever is having. So that is the logic behind it, and how that is this is how it works. So the question uh, 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 yeah, so let's try to figure out if we can find any way to handle this. So we need to find a shortest way to visit all the nodes, uh, and we can start from any node. That means I can start even from 0, I can start even from 1, I can start even from 2, 3, 4. I can start from any node. I can even repeat the path. If we want, we can also repeat the path. If we don't want, we will not repeat the path. Okay. So here what I can do is I can keep all the nodes in our queue, and from all the nodes we can visit all the other node, right? This is bidirectional, but we need to count the number of times we are going from here to there, so that even if we are handling 2, we are going from 2 to 3, then going back 3 to 2, then going back 2 to 3, this will increase the count, and increasing the count will always go backward, because it's a we will be using a priority queue. So priority queue will do what? Priority queue will make it the shortest traveled path at the top and not the longest one at the top. So shortest will be kept in the top. So this is how our logic will go. And uh, we need to know that have we visited that node or not. So I need to keep track. I need to keep three things in track. First, the shortest will go based on the count, number of times we are moving from 2 to 3, 3 to 2, 2 to 3, 3 to 2. That is my count. The second part will be my path, or I would say node. And the third thing which will be visited. These three things we want. We want count, that's for sure. We want the node, that's for sure. Can we remove this visited? Can we remove this visited? And if we do not know what all nodes I visited, how I will get to know that we are at the end? So we need some way or other visited. Okay, let's see how he did. Siny created a graph map with this. I don't have any problem with this. He created a vector. He created a normal queue. Why not priority queue? He created a vector, a set. In queue we are pushing three things: the current node, the number of times, and one left shifted I times. That means 2 to the power 2 to the power I, I in set we inserted this I and one left shifted I times. Okay, so I pitched all the nodes 0 1 2 3 4. Okay. While q dot size auto a, I took the front value. uh, Pop if a of 2 is equals to 1 left shifted n time minus 1 return a of I. A of 0 1 2. This is the count we are returning. 1 left shifted n times. This is actually handling that instead of making it more than 2. I need to understand things, particularly this thing. Now if I have this 0 1 2 3 4, so n is nothing but I think 5, right? N is 0 1 2 3 4 5. Total n is nothing but 5. Graph dot size, right? 5. uh, why I added minus 1 over here, I don't know. Let's see. 1 left is shifted 5 times. 0 1 0 times it will 1 time 2 time 3 time 4 time 5 time. So 0 time 1 time 2 time 3 time 4 time 5 time. So 1 2 4 8 16 and 32. This set, okay. Let's do one thing. Instead of going to, if you don't know, let's watch a YouTube video. A short tutorial would be better enough. Let's take an example not given in question. Graph to us like 1402 1324. We see our constraint, that is, we may are able to explore all possibilities, and all those possibilities we find the shortest path. Suppose if there are n nodes, then how many total possibilities we have? 2 to the power n possible path of n nodes. Whenever we encounter we apply BFS to solve it, because BFL will guarantee us to be the shortest path. Now we know that we have to explore all possibilities of a graph. Then we need some variables and data structures to avoid a repetitive path and to know whether we explore all other nodes from this current node. Variables, we need mask. This will tell whether we explore this path or not. 1 for visited, 0 for not visited. Fine. Node, this will tell us the current node we are exploring. Cost, this will tell us the total cost used in the path. Set data structure, it tells us which path we have already visited. It wants us to not to travel the repetitive repetitive path. How mask will help us? Let's take an example to understand it better. Let's understand this. Suppose we visit a node, say 2, say 2. Then we represent it using our bit mask. How? We make a binary value like this, 100. Here we make 1 to our position 2. It says that we have visited our node present on position 2. Right, correct. So bit mask, maybe let's make it so 0 1 2 3 4. Bit mask helps us a lot. It says something what we say array. Bit mask is a good thing to approach to. So we make a binary value like this, right? 0 1 2, that like 2 is visited. Here we make 1 to our position 2. It says that we have visited our node present on position 2. Since binary numbers read from right to left, so position is like this. Fine. Position 0 1 2, and we have binary value 0 0 1. It's totally fine. This is what I made over here. Now how we will reach to 100? If we change 100 to decimal, then it comes out to be 4. Oh, okay. He's saying that. Okay. Comes out to be 4. And 4 can be represented as 2 to the power 2. Read it as power of 2 of node 2. We have node 2 and we make power of node, then it changed to our mask. Similarly, if we say we have visited node 3, then we represent our binary value like this. Right. This will say 0 1 2 3. This is say, so this is nothing but 2 to the power 3, which is nothing but 1 left shifted 3 times, which is indirectly 2 to the power 3. 2 to the power 3 is nothing but 8 0 1 2 is 1 2 4 8 8 is set. Here we make 1 to our position 3. It says that we have visited the node position 3 to 1 0. We have binary value 1 0 0 0. Perfect. Now how we will reach to 1 0 0? 8 to the power 3. Masking. Now I got the masking part. Some important points to understand from code. Another sum important to be noted. Oh my god, used. It's not huge. The code is not huge. It's commented everywhere. That's why it looks huge. Take help from this article too. Yes, I will give you let's understand. Okay, we understood this part, bit masking, summon. Now we know uh, now we know how we know how we okay, now we know how we represent our nodes to mask, but since we are exploring path, then we should also know when we traveling from a node to another node, then how our mask will change. Let's take an example for better understanding. Suppose we are standing on node 2, then in bit it is represented as 100, right? Correct. 2 is 100, right? And also let's say we travel from our node 2 to node 3. We also know if we visit our node 3, then in bit it should be represented as 1000, which is this, correct? So how we will make changes in our bit so that we can say that okay, if we travel from node 2 to 3, then according to this our bit changes. So see, by using bit, what we are trying to say, that we make 1 to our position of node. Means if visited node 2, then we make 1 to our position 2, that is 100. And also if we visited to our node 3, we make 1 to our position 3, that is 1000, right? But when we travel from node to 3, what we will say? We'll say since we are standing at our node 2, then definitely our position 2 is to be 1. But also since now we visit to node 3, then definitely we have to set our position 3, that is to make 1. So if we present this, then how it should be like this? Correct. We have a binary value that we from 2 to 3 we have visited. We have visited 2, we have visited 3. See, on position 2 we have 1 and on position 3 we have 1, which says that we visited our node 2 as well as our node 3 also. Correct. And now our final answer is 1100. So can we relate them using mathematical type thing, right? Something like or. We have already this, we are going to this from this, so we are oring our previous with the next. Something, since property of or is correct. Now next point is, since we do not know on starting which node we get our minimum path, so initially from nodes we stroke mask and values in our queue. Since we don't know on starting which node we get our minimum path, uh, which node we on starting which node we get our minimum path. So initially for nodes we store mask and values in our queue, right? We make a set of pair type that will tell us which path we have been already visited. Since we have to take care three values at a time, so we'll make an class for that. We can also use pair of pair to do the same thing. Here I use class. We can use vector instead of using pair of pair or class. We can use vector. If we visited all nodes, then what should our mask value look like? Suppose we have three nodes, then our mask should look like 111. All three values. Decimal, it comes out to be 7, which is nothing but okay, 2 to the power 3 minus 1. Read it as power of 2 of 3 node minus 1. So if we visit all nodes, then at point our mask should be equal to all is power of 2 total number of nodes minus 1. Suppose if there are n node, the mask visiting all node looks like 2 to the power n minus 1. Correct. So he created a class to carry three values at a time. So we have tuple, tuple. So we have a node on which current node we are standing, mask of that node, cost of the path exploring by this node. These are the three values. Total number of nodes present. Int and graph dot size, extracting size of graph. So we have queue tuple of this tuple type, set to take care which path we have already visited. Okay, this is what which path we have already visited. Why we are caring about which path we have already visited? I don't know. This is my all. If all nodes are visited, we don't know which node will give us the shortest path. So initially for all nodes we store in our queue. For all nodes we will store in our queue. So all node, this is its own mask value, that is 2 to the power I. totally fine. 0 1 2 3 4 5 starting. So tuple, what is this node? I mask value I 1. I is the node, its mass, this is its mass value, and this is 1 its frequency, its count or its cost. Q dot push this node. Acha tuple this node, and this is the constructor, right? uh, Visited dot insert I comma mask value. This visited part, I need to understand this visited part. I'm not getting the visited part. This is the node, and this is the mask. While Q is not, I took out the tuple from Q dot front, popped that from the Q. If current this current dot mask is equals to all, return current dot cost minus 1, because we started from 0 from 1, we need to reduce it. Right, current dot cost minus 1. If not, start exploring in its adjacent. Now we will be exploring its adjacent. Graph dot current node adjacent. Bitwise mask is this current mask, right? This is current dot mask, both visited mask. Both visited mask is both visited mask or with 1 and the adjacent node. One left shifted adjacent node, that will make it that will make tuple of this path I created, so it will be one more cost. So visiting from 1 to 2 and 3 to back to 2 is something different, which this mask visited is giving me. So like visiting from 1 to 2 0 is marked, 1 is marked, rest is not marked. Now I go from here to here. Here is it is 0011. From here, if I go here, it will be marked as 0111. Right? And if I have something here which is 1111 0 from here to, and if I go back to here, this is something different, and what we got from here is something different. Okay, so this is what we are tracking. If we are coming from other place, now suppose if we go from 2, if we go back to 1 and we come back out to again 2, I saw that the same thing will be masked. I've already visited that, it's already in my queue. Why I will do add the same thing in my queue? Why? Okay, that is something unique and something different. Say visited is equals to, if we have not visited, the same node and the same bit mask, will insert it and this new node will be pushed. This is something good, something classic. Masking, it's always good to use a class. So let's solve it. So I used a class which will contain 3 things: and node, int the cost, and int mask. Now this tuple constructor will get 3 things: int node, cost. Int mask, right? So this node is equals to node, this cost is equals to cost, and this mask will be equal to mask, whatever we will be getting. So we created a constructor and everything. This class will be closed. Now I will be creating we have a graph, we need to create a map, right? 0 1. So I need n is something which will tell me the size of the graph. and 0 is connected to 1 2 3. So the graph is already present. I don't have to create the graph again, it's already there. So making adjacency list is not worth it because this is the adjacency list. Fine. uh, okay, so next what I will be doing is creating a tuple. uh, I need all the nodes to be inside my queue. So let's create a queue first. Queue will be of tuple type. Let's name it as queue. Okay, now let's visit all the nodes in the graph and push it in my queue, because I don't know from where I'll start and where I'll end. So for that I'll push it in my queue. So I'll create a tuple new tuple. New tuple will have mask, some mask. This is my start, so let me make it new mask only. So new mask is nothing but one left shifted I times. So node is I, the cost is 1 or maybe 0. Mask is new mask. Right, and I created a new tuple and I will push it in my queue. New TOUPLE. Marked it as new tuple. Pushed it in my queue. Fine. Now I need to iterate over my queue and find the shortest path. So while not queue dot empty, while queue is not empty, I'll take tuple current TOUPLE. Current tuple is nothing but queue dot front. I'll pop this out from here. Now all mask means everything is visited. This will be the first time. So all mask, I need something named as all mask, which is nothing but 1 left shifted n times -1, which will give me the last value. Okay, fine. So if my all mask is equals to my current tuple, dot it's a class, I can access it with dot current tuple dot, what's the name, mask, mask, right, mask. If that is the case, I'll return current tuple dot cost. Fine. Now I will be iterating over this array, this graph of current tuple dot node plus plus I. Sorry, current tuple dot node dot size. It's I new node. New node is nothing but current tuple of I. This will give me the new node. I need a new bit mask also. New mask, like the current mask. From current mask, I'm visiting to this mask, right? So current mask is something inside my current tuple dot mask. I'll OR it with one left shifted my new node, which will give me new mask, right? One thing that if this I'm visiting this new node with this new mask, if somehow I from this node I get back to the previous node, and from that previous node I again get back to this new node, that will be my same node and same mask which I've already visited. So I don't want that. I want node and mask to be my what should I say node and mask to be my visited array. So I need something in my visited. So for visited I can I need node and mask both in my visited. I can go for set, I can even go for another map, but map, it's just I need something. A set of pair maybe. New node is integer and integer visited. So I need to check if this visited dot find this new node and new mask. It should be visited dot end. It should go visited dot end. If it is not there, I will push it in my queue, and also I'll add it in my visited. So this is new node comma new mask, and in my queue dot push I'll have to create a new tuple for this TOUPLE new TOUPLE new tuple with what values. I need node, cost and mask. I need node is new node, cost is the current TOUPLE current tuple dot cost, and new mask. New TOUPLE. I inserted in my queue this new tuple. Okay. And at last, if we do not find any path, I may return -1. Okay, let's make it public for now. Oh, okay. Cost is current tuple dot cost plus 1. So if we submit this, got accepted. Great. So we understood the concept. We understood everything which was here. We created a class. We of node, cost, and mask, because we need the node, we need the cost, we need the mask. Earlier I was keeping a vector in this, but mask keeping a mask uh, is very much helpful, because it it works exactly same as my what should I say, it works exactly same as my array, but we can reduce the confusion and the complexities of everything. It's very simple, it goes very simple. So I will keep this valid bfs. After valid bfs, new file, this is multi source bfs.cpp. I have this comment from a point to that point itself using minimum path. We can go back and forth between nodes but should never land on the same config again. Yes, this is what exactly, we never land on the same configuration, because same configuration I'm tracking it with my visited. Great. Worth understanding this question. This question was worth understanding. Nice. Okay, fine. Okay, then let's take a 10 minutes of break. After that, we'll understand word ladder to boredom. I have to have complete understanding of all the BFS part, everything, mm, in a crisp way. So word ladder 2, I will at any cost. How much time it will take, I don't know, but I have to understand it. And then after completing boredom, this this will make my BFS very 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 strong. Okay. After that, I can go for DFS, then cycle detection, topological, MST, DSU, shortest path. There's lot of thing that I need to cover over here. which is only in graph. After that, I have to go to dynamic programming. Dynamic programming has these three questions. Then segment tree has these two question. Rolling hash, one Rabin card, and for the rest of the topics, it's a, so the biggest part is graph. What I can see from here, no problem. I'll cover that part. But first, I need to make my what should I say, graph strong at any cost. So let's take a 10 minutes of break, and after that we'll go with word editor to boredom, and then DFS. DFS has one, two, three, four questions. Okay, cycle detection, lots of question, topological. Let's give our time to this graph. Shortest path algorithm is always needed. Dijkstra, Bellman Ford, Floyd Warshall. This should be in my on my tongue. Strongly connected. Kosa Raju is always one of the good, bad, better, best algorithm. I don't know if I'll be covering this articulation point and bridges or not. Let's see. But till 9, I'll be covering this. So I'll be back in 10 minutes. Let's not waste much of our time. Okay, I'm back. Let's go. So we solved this valid BFS, multi-source BFS. We understood this multi-source BFS, and I think um, rotten tomatoes and or sorry, oranges, rotting oranges, and all those questions are very much similar to these things only. So I'll not go to those questions. I'll go with word ladder 2. It's really good learnings. We made the DAG using BFS, then applied DFS to find our source to destination. I brought something to eat. Kaju. Okay. Let's see what this word ladder is. I'll try to solve this question also. And this one also. This is premium. As far from land as possible. Rotting oranges, no. I'll try this one also. Uh, okay. So the question is word ladder 2. Why this word ladder 2 is so much famous and what are we doing over here is something very good. A transformation sequence from word begin word to end word using a dictionary word list is a sequence of word begin S1 to SK such that every adjacent pair of words differ by single letter. Every S1 in word list. Note that begin word does not need to be in word list. SK is end word. Given two words, begin word and end word, and a dictionary word list, return all shortest transformation sequences from begin word to end word for an empty list. If no such sequence exists, each sequence should be returned as a list of word begin. So from hit to cog, from hit to hot, hot to dot, dot to dog, dog to cog. This is the shortest one. And there is one more which goes from hit to hot, hot to lot, lot to log, and log to cog. This is what are another shortest. So I need to find all the shortest. First we need to find the shortest. Okay, if we find any of the shortest, so word ladder 1, if I remember, if I go with word ladder 1, okay, just give me a minute. I'll be back in a minute. I'm getting a call. Okay, I'm back. I'm sorry for the delay. I got a call from my father, so I had to pick it up. uh, okay. Okay, let's go next. So this is word ladder 1. It's same, but in this case what we want is the length of the shortest path. So let me see how I solved this. So I have a begin word, I have an end word. So I started from begin, added it in my queue. I should add it in my queue, and after that I picked that word from my queue, and I kept this in my map. I kept it in a map so that I can search it for over one time, right? And I changed every letter because word length word length is 10 only, so I will go maximum till 10 length, and every length will go till 26 into 26. So 10 into 26, something like that. Okay, 10 to 26. So every word, and if we found it, will push this in my queue with the count, with its count, whatever count previous had. I'll plus 1 and push it in my queue, right? Correct. Okay, so from hit to hot will be pushed, hit will be popped, because we don't want hit now. This is the logic behind it. So I'll have an ordered map or a set. It's fine. Set, because I don't need I'll insert all everything in my set. I'll keep a queue of string and integer. String will contain the word, and integer will contain its count. So if a string is equal to end word, I'll return the moves. So this is my string, this is my moves. I popped it out. I popped it from my queue. Now here I is equals to 0, I is lesser than str dot size. I picked a character A, I went till Z. I went that string dot size. I went till Z. Okay, I can do something like this. This is good. So strs is equals to stri. So s of I will be this new ch added. Even this can be removed and can be added over here. I don't need this. This will hinder my logic. So I changed this character, and this m dot find s is not equal to m dot end. It's there in the map. I'll erase it. Why I erased it? Because I reached that. Now I don't want from somewhere I go to that again, because this is the shortest. I pushed it in my queue. If I don't erase it, that will be a problem. Else we'll have to make a visited array, that I visited this. I don't want to go there again. Correct. Right, right. Why we didn't use priority queue over here? Because every time the count, the second part, will be in a sequence only. 1, then 2, all the list of 2, then all the list of 3, then all the list of 4, then all the list of 5. In that case, we don't want priority queue. We want only queue, direct queue. Correct. And that is the reason I erased it, because I reached the shortest path. Correct. This is fine. Now the same thing with some twist. The twist is, earlier I was finding that I need to find the path. Earlier we were finding count, and now we need to find the path. Now there is some tricks involved over here. I know that. Else we could have directly gone to the previous. Instead of keeping the count, we could have kept we could have kept pair string, and this time vector of string. Kept string, vector of string. The same thing I followed. I kept it in my map. Begin word and answer. Did I use priority queue for this? No, I used queue. Why I added len to erase? If str is the end word, result dot pushback my answer, and we'll continue. Else we'll do here something. Str dot size, same character A going till Z, took changed it if it is not present. Because we can have multiple we created a joiner. And joiner dot pushback s, right? Q dot pushback s and joiner. Okay, this is fine, but it will give me time limit exceeded. It exceeded the time. 32 out of 35 test cases passed. So we need to do some more things over here. Can we watch a video for this tutorial instead of going through code or something? We can watch the tutorial over here. Word ladder to or even a solution. C++ solution using standard BFS method. Because nearly all the solution on the web is too long or too tricky and can be hardly be remembered during the interview. In fact, this problem can be solved with a standard BFS process whose structure could have been written for you for many times using while loop and a queue. The following code is written in a very standard BFS method which is easy to memorize. The only tricky thing you need to remember is this BFS of path, not words, is a vector. That's it. I need 2 minutes more. Sorry.
से करना शुरू कर रहा हूँ DSA, अभी नहा के बैठूंगा।
ठीक है। Okay, so we were in word ladder
कल
two.
मैसेज आया था उसका।
किसका? एक second. Let's go. How far? I need to understand this. What led it to lead code? Let's see. Optimized approach for lead code. Let's see this. How we are handling. I don't know if you will be able to hear the audio. Display capture. Let me check. Okay.
रीच ड्राइवर किस लिए रूल करेगा कॉपीराइट स्ट्राइक और क्या
Okay. Let's see the previous one then. It's The first solution was exactly same as I solved in word letter 2, but it is not getting submitted on lead code, of course, as what he said. So I'll try to see the optimized one also. Okay. Something hack that we did in the new one. But I suppose I should go for the older solution only. In this, I should not go with some newer solution or some variety of solution. So the submission that that when time limit exceeded is actually the one which which will be accepted for the interview part. That's what uh, it is saying. So let's just try to code it out. Even though it is giving me TLE, I don't have a problem. Let's try to code it out. So we have a begin word, we have an end word, we have the word list. So word list will be kept in my map. So this word list I'll create another map. Even set will work of string type. St string type list. बोला था मैंने, फिर पता नहीं वो देखी नहीं, वो कुछ बोली नहीं, चली गई। तो पता नहीं भूल गई या क्या होगा, पता नहीं। हाँ, हाय सर, बिग फैन। थैंक यू प्रसून भाई। तुम साथ में कर सकते हो if you are that much big fan. List map. I is less than word list dot. So word map, maybe I'll make it word map. Word map. Word map dot insert word list of I. So this is what I created a map. I'll create a queue which will keep vector of string queue. Now this queue will start with my begin word. I'll insert this begin word in this queue. It's a vector, so I should start it with normal vector. Now while my queue, not queue dot empty, I should iterate. So I need to vector current word current list which is nothing but q dot front, I'm picking up the current list from there, and from current list I'm picking up the last one, mm, current string, which is nothing but current list dot back. And always pop it before doing any operation. I picked this part, I popped this. Now I should I remove it from word map? I should not remove it from my, until and unless this whole operation gets completed. So for completing the whole operation, I need a length. Len is equals to q dot size for into, so is lesser than len plus I. So inside this everything will be all the operations will be done. Okay. So after doing all the operations, current list dot back, I got the current list dot back. I need to check all the words around this current string. So what I will do, I'll start a char ch which will start from a, so then equals to z and plus ch. This will do. Now this is my current string. Original str is equals to current str. Every time I need to change it, so current str, now every word of current str should be changed and then mapped, correct? So instead of doing it directly, let's okay. So we'll do what? We'll do for loop str dot size plus j. This will iterate over all the words. I'll just copy a new word and I'll paste the part. So current str of j will be replaced with this new character. Now I need to check in my word list whether this character is present or not. So while, no, not while, if this current character is present, so cur str word map dot count current str is greater than 0, that means this word is present. So we cannot directly remove it. I need to keep track of the words to be removed. I so what I will do, I will add this new str current dot uh, push back current str and q dot push back mm, in queue I'll push back this current list, and after that I'll also remove from current list dot pop back, because I don't want it to be there, because we may find some other strings also. So after this original str, current str will be again reversed to original str for the next character. So for the next character we are iterating this again. Okay, now I want one thing, that if this strings whole part is completed, uh, now I can remove this uh, original string from my map. So this is my word map. Just a second. Word map dot erase uh, original string. Why I am doing that? From this word I can go to that word. So this word from this word I can go to many words. So this word's completed. That's what from. So I got this original string. So I need to create my answer now. Uh, vector vector string result. Now if my result dot size is equals to 0, that means this is the first time that we are encountering this. And wait, if original str is equals to my end word, if this is my end word, and now if result dot size is the first time that we encountered, so I'll directly push it in my queue. Result dot push back current list else there will be one more condition, that if current list dot size is equal to Mm, current list dot size is equals to result of 0 dot size. If this is the case, then also result dot pushback current list. And at last I will be returning my result. Oh, sorry, it should be string type. Oh, sorry. Q dot push. Oh my god, so silly mistakes. So it will surely give me a time limit exceeded, or even not, then maybe wrong answer. But it's memory limit exceeded at 33. So they increase the test cases, more added. No. Yeah, earlier there were two more test cases they added, and this time they added memory limit exceeded test case also. But yeah, this works. This will do our job. So I'll just copy it and I'll save this as a word ladder. .cpp and paste the code here. Fine. So this is how we will be doing this. Nice, clean, concise. I think everything is understandable. Okay. So after this, I will start with the next question is boredom. I don't know what type of question is this, but let's see. Boredom. Is it on lead code? Very bored, useless problem. Wow. A boredom code forces around 260 div 1. This is I think boredom. Yeah, it's 455A. Alex doesn't like boredom. That's why whenever he gets bored, he comes up with games. One long winter evening, he came up with a game and decided to play it. Given a sequence A consisting of n integers, there are a total of n integers, the player can make several steps. In a single game, he can choose an element of the sequence. Let's denote it AK and delete it. At all elements equal to AK plus 1 and AK minus 1 also must be deleted from the sequence. That step brings AK points to the player. Alex is a perfectionist, so he decided to get as many points as possible. Help him. Perfectionist. The player can make several steps. In a single step, he can choose an element of the sequence. Let's denote it AK and delete it. At that, all elements equal to AK plus 1 and AK minus 1 also must be deleted from the sequence. That step brings AK points to the player. Okay, if I'm deleting AK, I have to delete AK plus 1 and AK minus 1, and AK points will be given to me. Alex is a perfectionist, so he decided to get as many points as possible. Help him. Considering the third one, 2 and 3, I think they. At first step, we need to choose element equal to 2, which will delete 1 and 1, obviously. After this, we are left with choose any element equal to 2. After that step, our sequence looks like this: 2 2 2 2. Okay, he's saying all the elements equal to oh. So if I'm deleting 2, so 1 and 3 will be removed. So all 1 and all 3 will be removed. Only 2 2 2 2 will be left now. Then we do 4 steps. Take this, take this, take this, take this. One each step we choose any element equals to 2. In total we earn 10 points. 1 2 1 3 2. Okay, nice. Let's try this question also. uh, I'll take a 10-minute of short break, and after that short break I'll come back and I'll solve this question. I'll try to solve this question using DP or even BFS if possible. I'll try to make as best as possible. So let's do it. I'll be back in 10 minutes. Don't go anywhere. Sorry, I'm back. A little late. I'm back now. Okay, so where were we? Mm, प्यारी तो है. Okay. So we were solving this boredom. Boredom. Okay, let's go. So we have been given 1, 2. Okay, I need to change the color. 1, 2, 1, 3, 2, 2, 2, 2, 3. We can do one thing. We can let's just sort it. So 1, 1, 2, 2, 2, 2, 1, 2, 3, 4, 5, and then 3. Now uh, we are left with something as 1 total sum is 2. 2 total sum is 10, I think. I need to add it, right? Brings AK point to the player. 10 and 3 with point as 1. Sorry, point as 3 now. Now from these I need to pick something like that. So if I pick 1, won't be able to pick 2, right? So it will be something like pick, not pick. If I'm picking specific and not pick some specific. So if I'm picking this value, if I'm picking this, so 1 with 2, if I'm picking 1, I will say the next pick to be at least 3, right? If I'm picking 2, the next pick will be at least 4. So it will be something like that. So I need to maximize. So I can use can we use BFS, like DP is one of the possible solution for this. We can go BFS. If we take 1, so 2 is in my answer. I know I have picked 1. So the next value that I can pick is minimum not 2, 3. Hey, come on. 3. Okay, so this is 2. I cannot. Okay. What we can do is let's try something with BFS. Pick this value, keep it in I can pick every value individually, correct? So I can pick 1 with 2 value, I can pick 2 with 10 value, I can pick 3 with 3 value, right? I added everything in my BFS. I will start from this. I'll pick this one front. I'll check what value can I pick. I have picked 1, so I know I cannot pick 2. I need to pick 3. So the next value, I need to keep the index. So instead of keeping the values, let's pick the index. 0 1 and 2. 0 has a value of 1, so I cannot pick 2. I can go with 3. So 3, adding 3 to it, this will give me index index 2 with value of 5, right? Index 1 has a value of 2. I cannot pick 3. I cannot go beyond, so this is my 10. So I'll keep an answer which will tell me which is the maximum. I have 2 with second index which is 3, value 3. I need to, I cannot pick 4 or 5 with this. So this will create a problem. I'll have to pick all the values, all the values. Into this. So this boredom, and this is something else, man. BORDOM BORDO. It's something yes and no. NM and vector. These are two integers and a given vector. So I took a vector, I called the solve function. Set long mp dot insert 0 long sum is equals to 0. Sum plus a of I plus is equals to a of I. Long sum is equals to sum minus m. While temp is greater than equals to 0. If mp dot find temp is not equals to mp dot end return yes. Temp minus is equals to m. mp dot insert sum. What is this? M. Let's try something I subtracted from him. added a of I value to it. If temporary is greater than 0, amp dot find temp. If I find it in my map, what's in my map, that value is already there. So till that value, my sum is, so it's not a DFS, BFS, or anything like that. It's just simply finding whether that m value exists, sum of the values, and check minus m is present or not. I should be positive. If it is not present, I subtracted it with my okay while temp. I subtracted, again subtracted, again subtracted, again subtracted. I'm going back, I'm back. This boredom and that boredom is different, but this boredom is also. See, I think it's a full DP problem. I would say pick and not pick based on pick and not pick. I've picked that index. Because it's a +1 and -1, and I'm checking just +1, so I need to check the next value. If it is greater than +1 value of current, I'll jump to the next value, or even else I'll jump to +2. Right, and then that will be again pick and not pick. If I'm picking that value, I will check, and if I'm not picking that value, I'll directly jump to the next index. I don't have to care about anything else. The new rule regarding the restriction on the use of AI tools. Oh, okay. They are applying restrictions on the AI tools. Use of AI tools. Nice. They are doing something at least. It's good. Okay. So this boredom, I'll solve it. But first of all, let's not deviate from our path. So this is something I'll look into it. But I have completed valid BFS, multi-source BFS, word ladder 2, multi-source BFS. This question, shortest path visiting all node, is a very good question. So BFS, it's I think I have solved lots of question related to this BFS. Not lots of question. I'll practice more question, but till now I know the concepts. Next, I'll go to DFS, depth first search. Reconstruction itinerary. Add reconstruct itinerary. Okay, so this is reconstruct itinerary, then connected components, then DFS with stopping condition, and journey to the moon. So, 1 2 3 4. So journey to the moon, let's start with journey to the moon, then reconstruct an itinerary. And what was this? BFS and its variation. Add to tab group. Chalo. dp of I minus 1 or I minus 2 plus frequency of I into I. Correct, it's normal, bro. I minus 1, pick directly I minus 1 or I minus 2 with map of frequency I of I into this. Correct, yaar. This is so simple and small. Without using DFS, we can directly go with iterative approach. So it's good. So boredom is not that much difficult. Journey to the moon. Journey to the moon. Okay, it's a hacker rank question. Okay, so the problem states that the member states of the UN are planning to send 2 people to the moon. They want them to be from different countries. Okay, 2 people to the moon, and they two should be of different countries. You will be given a pair of list of astronaut IDs. Each pair is made of list of pair of astronaut IDs. Each pair is made of astronaut from the same country. Determine how many pair of astronauts from different countries they can choose from. Example, N is 4, astronaut is 1 2 2 3. There are 4 astronauts numbered 0 to 3, 0 through 3, 0 1 2 3. So ID will tell it is they are from which country. Astronauts grouped by country are 0 and 1 2 3. There are 3 pairs to choose from, 0 1 0 2 0 3. I didn't get it. Complete the journey to moon function in editor below. Zero, 1, 2, 3. The member states of the UN are planning to send 2 people to the moon. Two people to the moon. Okay, they want them to be from different countries. Fine. You will be given a list of pairs of astronaut IDs. Each pair is made of astronauts from the same country. Determine how many pair of astronauts. I didn't get it. Persons numbered 014. The first one can two integer n and p, the number of astronauts and the number of pairs. 5 astronauts, 3 pairs. Each of the next p line contain two spaces separated integers denoting astronaut IDs. Total 5 astronauts are there and 3 pairs are there. So 0, 1, 2, 3, 0, 4. Two spaces separated integer denoting the astronaut IDs of two who share the same nationality. Who share the same nationality. Persons numbered 014. 01 and 04 belong to one country. Correct. And those numbered 2, 3 belong to another. The union has 6 ways of choosing pair. Zero two zero three 1213 4243. 4 astronauts and there are total 1 pairs. 0 and 2 belong to same countries. That means if 0 and 2 belongs to the same country, there are 4. 0, 1, 2, 3. So 0 and 2 are together, 1 is separate and 3 is separate. So one pair can be 1 and 3, one pair can be 1 and 0, 1 and 2, with 3 and 0 and 3 and 2. 3 and 1, correct. 3 and 0, 3 and 2, 1 and 2, and 1 and 0. So there are total of 5 pairs possible. And above here there were 4 astronauts numbered from 0, 1, 2, 3. So 1 and 2 and 2 and 3. That means 1, 2 and 3 are together. 0 is separate. So 0, 1, 0, 2 and 0, 3. Okay. So this is how it is approaching. So the main concept of the crux is I need to find these lists. Okay, so I need to find these lists and I need to keep it somewhere. So 1 to 2 and 2 to 3. Okay. So there will be few nodes which are not present, which can tie up with if like they do not belong to any of the country. If there are IDs which are indivisible, we can pair them with all the others. We can pair them with all others. Correct, right? So I don't have to care about the individuals. I only have to care about the one who are in groups. So 1 is grouped with 2, 2 is grouped with 3. So 1, 2 and 3 are grouped together. Similarly, if I see here, there are 3 groups and 5. So 0, 1, 2, 3 and 4. There are total of 5 astronauts. 0 and 1 are in same. 2 and 3 are in same countries. 0 and 4 are in same countries. 0, 0, 1, 0 and 4. So it might be possible it will be given 4 and 0. Correct, right? So I need to traverse both ways, 4 0 and 0 and 4. So 0 1 or 1 0. This will be 1 comma 0. So from 1 I went to 0. From 0 I can go to 4, right? So whatever list are there, I will directly simply add it in my list 0 1 and 4. After creating a list of something like this, two 3, now uh, I can even keep it in a map, values in a map, so that I can get to know that what values are missing. So 0 1 2 3 4 all are there. So maybe if astronauts were 8, suppose 8, so 4 5 6 and 7. So we know that 5 6 7 are independent of each other, they are not in any of the group. So what we can in this these two, what we can do is 3 into 2, they'll form 6 pairs with each other. Individual they'll go with each other, individually they'll go with each other. So 3 2 6 plus 5 6 and 7, they are individual, so they can go with all 1 2 3 4 5 6 7 extra 7, so 7. They this can he can also go with extra 7, he can also go with extra 7, right? So 21 plus 6 will be something 27. So total possibility is 27. Right. So total possibilities are 27. If there were more, like 5 and 6 were also there, what would have happened? This can go with this. Total sum is 1 2 3 4 5. So they both can go with each one can go with individual 5, right? So 5 multiplied by 5 extra will be added to this 6, then plus into 2, like not 5, sorry, 5 multiplied by there are 2 and total 5 to 10. So total number of nodes are 5 into 2 will give me 10. So 6 plus 10, that is 16. 5 6 and 7 is individual, so for individual 1 2 3 4 5 6 7, 7 more. So 23 total you can make. So we just have to figure out the groups. what is this? Okay, this is the one. Why you are giving me these things? I don't want. I don't want to know any of these things. It's fine then. We have n. We have astronauts vector. So uh, from this astronaut vector, I can create a graph adjacency list. So vector adj adjacency list of size n, correct, because the values will be size n. Now let's naut astronaut dot size plus plus I adj. So I have a as astro naut astronaut of I have 0 int b as astronaut of adjacency list of a dot pushback. Adjacency list of b dot pushback a. There's one thing that I need to know, like from if I went from 0 to 1, I cannot go from 1 to anywhere. But if I go from 1 to 0, I can go from 0 to 4. But if I mark these two as visited, won't be able to reach 4. Okay, for this I can use DSU, but I don't want to use DSU, I want to use DFS. So how to handle this part? Whatever given, should I follow this or will there be a loop? Like 1 to 2, 2 to 3 and 3 to 2 back again. In this case 0, 1 and 4 are together. Two, three are not. What I can do in that case, from 1 if I start, I can go to 0, and if I start from 0 I can go to 1, from 1 I can go to 0, and 0 I can go to 4, but from 0 I went to 1. And from 1 I sorry, oh, what what I am doing is something wrong. This will be here, right, isn't it? So from 0 if I start, I can go to 1. From 1 I can go back to 0. I do not, I fall back. From 1 I can go to, from 0 I can go to 4 also. So if there is a new node, yeah, it's fine then. From 4 I can go back to 0, but 0 I've already, so it's fine now. It's fine, sorry. I was thinking something else. It's fine. This will do the job. So I need to create a list. Uh, group list. This will be my group list, and I need a visited node, whether which will tell me whether I have visited this node or not. So now I'll start my array. Start my DFS if visited of I is equals to 0. That means I haven't visited it. I'll call a DFS to create a group. To create a group. So this will return me something, some count, right? And I must be having some previous sum. Previous count, which will be 0. And after calling this DFS, I don't want this group list. So this is a new count that I got. From this new count I will this new count will be multiplied with previous count, and there will be total sum, which is nothing but 0. So this total sum will be plus is equals to total sum plus what I did was multiplying. I got 2 from here. I had total count of previous count of 5, so 5 into 2. So previous count into count, and now my previous count will be added with this count, and at last I will return my total sum. Now this DFS will have this my as start node, 0. From can I go anywhere? Let's see. So I have this DFS with myself, and DFS will do what? It will take node. I need to pass my graph also. It will take node, it will take count will be as pass by reference. Okay, and this adjacency list. Now I also need to pass visited node, visited, and accept it here. Okay, so this will iterate over this node list. So for int I is equals to 0, I is lesser than adj list of node dot size plus plus I. Now if node is visited, if new node, I need to create a new node. adj of list of node of I. Visited of new node is equals to 0. That means I haven't went to that node. I'll make it visited new node is equals to 1. And I'll do a DFS call of node count plus 1 adjacency list and pass my visited. Now I need to do one thing. So this DFS will also I need to pass this count over here. And visited of cannot bind a non-constant value reference type integer to I. Let's say I passed it a variable. I passed a variable count, adjacency list, and the visited. What what error is it saying? It's a warning. It's a warning error. This is a void. Error cannot bind non-constant L value reference to type integer. What binding problem is this? Initializing argument 2 of note no return statement in non-void 27. Where I did void. What the fuck? This is a warning. That's fine. This is the error. Cannot bind non-constant value a reference of type integer ampersand. But why? Let's make it then int. Remove this. Int. No, I don't want this count. Count plus 1 where I 4102. My output is 7 and 5. My output is 7. So 0. So from 0 I went to 1. From 0 I went to 1. I have 4. 0 1 1 0 0 1 1 0 2 2 3 3 2 2 0 and 4 4 and 0. So I started with 0 0. I checked, can I go to 1? Yes, I can. If I can go to 1, I went there. From 1, I made this 1 as visited, marked this 1 as visited, 0 as visited. So I have this visited array 0, 1, 2, 3, 4. I marked this 0 as 1, 1 as 1, rest is 0 till now. From 1 I can go to 0. Can I go? But it's saying it should be 0, but it will not go. So it'll fall back and return count passes 0 plus 1, that is 1 over here. Again it will go to, so count will be stored with count is equals to count plus, so count will store 1. From here I can go to 4. From 4 I can go to 0, but I will not. I'll retreat back taking 1. 1 plus 1, that is 2. 2 plus 1, that is 3. So 3 will be returned from here. 3 will be returned here in this count. Previous count is 0. So total count will be previous count into current count. Current count is 3, which is 0. Total sum will be 0. And previous count will be added with current count, which is 3. So 3 added. Next 1 is visited, 2 is not visited. 2 to 3 and 3 to back to 2 again, no. So it will return me 2. So 2. So previous count was 3. 3 into 2, that is 5. Total sum will be added with 5. So it should work now. Why it's not giving me 5? Okay. 0, 1, 2, 3, 4. Six ways of choosing pair. Oh, okay, okay. But I marked it visited, right? Bro, I marked it. What's wrong? So for second case, it's, let's see. Second case is very simple. 4 and 1. there are 4 nodes, 0, 1, 2 and 3, right? And 0 2 are together. So there are 4 nodes, so 0 1 2 3, something like that. And there will be 0 to 2 and 2 to 0. I'll start from 0. I'll mark this 0, 0 as 1, marked this as 1. DFS call is equals to astronaut I of 0. 2. I marked new node 2 as also 1, right? Hey, I'm calling the node only. Still, okay. Now 2 is also 1. From 2 I can go to 0, but I cannot, so it will return. From 2 I wanted to go to 0, but I cannot go to 0, right? So it will stop here and I'll fall back and I'll return node value is 2, right? So 2 plus 0 plus 1, that is 1 over here. Cannot go, so 1 plus 1, that is 2. 2 will be returned. So initially 2 will be stored. So okay, and 1 return what? 1. So 1 into 2, that is 2. 2 will be 1 into 2, that is total sum plus previous count into, so 1 into 2 will be 2, right? So 2 will be added in my total sum. Now next is 3. 0 is done, 1 is done. So instead of this, can I print? Can I see out I? What is the count that is coming. Can I print it? 'Shit. Oh, 11th. The return type is integer. Journey to moon. Expected output is 499999. One digit कम ही आ रहा है मेरा. Maybe I'll keep long. I don't know. Why this test case output is wrong? I don't know. Rest of the test cases are successfully completed. Fine. This journey to the moon should have. What mistake did I do? I need to rectify the mistake. So whenever we are reaching to a new node, I need to return +1. So adding extra, these are, they were adding extra. Yes, correct, I got it. It's all about imagination. If you don't imagine, if you can't imagine, you won't be able to like think properly. It's fine. Okay, I'll take a 10 minutes of break. I'll try to order something. I'm really feeling hungry right now, and then we'll jump back again and we'll start doing coding again. So let's see. Whenever the food will arrive, I'll take 20 minutes of break in between because I need to eat. So I'll keep a short break only, not a long break. So I'll be back in 10 minutes. See ya. I'm back. I'm back. I'm sorry. I'm sorry. I was talking without even seeing. Okay. So the next question is maximum path quality of a graph. DFS with stopping condition. This is something with some stopping condition. I want to stop somewhere. This was a pre-planned DFS, direct DFS. Now I have to stop somewhere. Okay, so let's go to this problem. Okay, there is an undirected graph with n node numbered from 0 to n minus 1. 0 to n minus 1 inclusive. You are given a 0 indexed integer array values. Okay, values. We are given a values list of values where values I is the value of the ith node. Value I is the value of the ith node. You are also given a 0 indexed 2D integer array edges. Where each edges of j is equals to u of j, v of j, time of j. Means there is an edge between ui, vi, and it takes time I seconds to travel between two nodes. Finally, you are given an integer max time, correct? A valid path in the graph is any path that starts at node 0, okay, and ends at node 0, takes at most max time seconds to complete. You may visit the same node multiple times. The quality of a valid path is the sum of the values of the unique node visited in the path. Each node's value is added at most once to the sum. Okay, return the maximum quality of valid path. At most 4 edges connected to each node. Note there are at most 4 edges connected to each node. Okay, so every node will have 4 edges connected to it. The total number of nodes is 1000. The values of each node ranges from 0 to 20 to the power 8. Edges dot length is number of edges will be 2000. Right? Okay. Let's understand this with an example. 0 1 10 1 to 15 0 3 10. Max time is 49. 0 32 10 43. 0 32 10 43. 0 1 0 3 0. Total time taken is 10 plus 10 plus 10 plus 10 is equals to 40, which is lesser than 49. So I have to start at 0, I have to end at 0, and maximum I can take is max time to complete. So I need to return the maximum profit that I can make. 0 1 and 3 giving. Okay, there are two things. These are values. So from 0 to 1, I reached So from 0 I had 0 values to 1, I added 32 to it. From 1 I again went to 0, which will give add nothing to my value. Even if it had 10 value also, it would have added nothing in the second time. From 0 to 3, which is 43. So in total of 75 points that we made. So I can visit starting 0 to 1 and 1 back to 0. I can revisit the same node multiple times. Ten and 10, 20, which is lesser than 30, and the maximum profit that I can get is 25. Which is lesser than equals to 50. The node visited are 0, 1 and 3, giving maximum path quality of 1 to 4, which is equals to 7. So what can we do in this case is starting from 0, I can go for a BFS approach and go to 1, and that max time, what's the max time that we have? It's 100 only. So even this values of I is time of j and max time is 100, 10 to 100. So it will be minimum of 10. So I can accurately say that if we even continuously go 0 1 0 1 0 1 0 1 0 1 1 0 1 0 0 1 1 0, something like that, it there will be a time where it will stop. The max time that is for 100. So every edge can go maximum of 100 value 10 times. I can iterate over every edge 10 times. That's the maximum that we can do. Correct. So that is a thing. And if it goes beyond the max time, I'll stop and I'll pop that out. I am not considering that even again. So from 1 I can even go back to 0. Again, what is the node? Just give a minute. Hello, hello, I'm back. Uh, I went for bringing my food. I'm really hungry. Really, really hungry. So the first thing that comes to my mind with this is if I start doing a BFS approach, we will eventually reach to zero. So wherever we are, we need to make sure that we are reaching to every other node and the values are being added to it. Okay. Now my brain is not working. I need a break. I'll be back with maybe 20 minutes break. That is enough. So for eating, even let's take a 25 minutes of break, and after that I will be back and will continue. I'm sorry, I'm really hungry. Hello guys, I'm back. Finally, my thirst has been quenched. Hunger, I would say. Okay, so so what I was thinking is from 0 to 1, even if I'm trying to go for DFS approach, BFS approach is also possible here, DFS approach is also possible here. I can try any of of them, not an issue. But if I'm applying DFS approach, I can go here and forth. The only condition which will break is when my time, when this time, when time of j is greater than my max time. If if this happens, I'll stop. I'll stop from at that point of time. So let's try to construct its BFS and, and see if we will be able to solve it or not. So at each point of time, I need to calculate the maximum values whenever we reach zero node back again. Okay, so I need to reach zero back again, right? So I need to find second time. So the values should be 0 should be encountered at the second time, not at the first time. So we need to keep track somewhere or somehow so that I can make sure that I encounter this 0 second time at each iteration, not the first time, because first time calculating value will not give me the optimal answer, will not give me the answer, because if there is only one node that is 0, we cannot reach again to that node. So if even if it has values 100, 200, anything, we won't be able to make it. So first of all, I have been given edges. I need to create a graph adjacency list. So let's just create a adjacency list of n nodes. So values dot size so can we create in note not word, Google Docs, where is Google Docs? What did I do? So this is the method. Vector int adjacency list, which will be of size n. Now I need to iterate I is lesser than e edges edges right edges dot size plus plus I. So at each point of time I'll be getting two values, int a that is edges of I of 0, int b that is edges of I of 1, list of a dot pushback adjacency list of b dot pushback a. So this is what we formed. Now this is done. Now what I need to do is I need to do a DFS call for this adjacency list and make sure it should not cross the max time that we have. And also I need to be careful that I visit 0 twice. Correct. So if I do a DFS call, in this case I don't need visited because I'm visiting the same nodes again and again, so it doesn't matter here for the visited one, but it do matter that if I have visited a node, I should not add the value of that node again in my answer. Correct. So DFS will be, I'll pass my adjacency list. I'll start with node 0. I should be having something, right? DFS in DFS I'll have only one path at a time, so I can create a set of integer visited. I need this visited. So let's see if it returns any value or not. Void DFS integer DFS. This is my node. This will be my adjacency list and this will be my visited. Now now the base case will be I need to pass the maximum time also, and I need to pass something which will calculate the value or sum. So I'll take max time and int sum. Or I don't know if DFS will have only one point path at a time, so I can use I can make use of that benefit. I can take the benefit of that. So what I can do is this node is visited. So if visited dot count node is greater than 0 and I need to make sure. Okay, I'll make sure that thing. If it is greater than 0, I'll simply return a value. Now if node is equals to 0 and if node is 0 and visited dot count of this node, oh yeah, this can be handled over here now. If node is equals to 0 I'll return some value. I'll return some minimum value which we don't want, so I don't need this condition. This is our base case will be. For now, let's see if I need to do any changes. For now, it's looking fine. Now I need to iterate over the adjacency list. Adjacency list of node plus I. New node is nothing but adjacency list of adjacency list of node of I. This is my new node. Now the maqsad is I don't think I need some, but let's wait and see. I need values also. Where is values? I need to pass values. Where is integer answer is nothing but 0. Now if this node, we haven't visited this node, this new node. If visited dot count of this new node is greater than 0, then we need to do something. else this is the first time that we are doing, then we need to do something. So if it is already visited, so we don't have to add the value. Right, so DFS will be called directly, which will in return will give me answer. DFS with new node adjacency list with visited, because that is already visited. Now now I need one thing. I have visited it, but if I visit it multiple times and I fall back from there, I am not removing it until and unless I visit that value twice, or zero last time. So for that, we instead of keeping set, I need to keep unordered map of integer comma integer visited. So instead of set, it will be unordered map of integer comma integer. I don't know count method works in or not. Answer plus is equals to DFS new node. If directly I can do this in map, if I will not add it in my answer, but I will increase. But I will increase my visited of new node plus plus visited this max time. Okay, we need a base case for max time also. Values, okay, and not passing my sum, else else I need to check after visited of new node. We'll do minus minus. Now if I haven't visited it yet, if I haven't visited it yet, what I will do is I will visit it, that is for sure. And answer will be something answer plus DFS with this new node maximum time values. Now int sum is 0 if mm, if answer plus values of this new node is lesser than or equals to max time. To move this sum, I don't know. Sorry. Let me if answer plus values of new node is lesser than equals to my max time, I will do the call, else I will not do the call. Answer plus answer plus not visited actually, sorry. Not visited values will be added, but here I need to check wherever I'm going that value, and I created a adjacency list. I created a adjacency list with integer value. This is not the case. It's a 3 integers. I need to have a pair of integer. Push back int cost is equals to edges of I of 2. So cost will be added over here. Then we will be doing this. Now the acceptance will be something like this of adjacency list over here. Now adjacency list dot I dot first is my node and second is my travel cost. Travel cost is adjacency list of node of I dot second. So I need to check my travel cost. I need to maximize, right? So answer will be maximum of answer comma this DFS value, right? And here also I need to maximize, so maximum of answer comma answer plus values of current and whatever we'll get in future. that value. So maybe I'll push it in 3 parts. So answer comma answer plus DFS, whatever it will give me will be maximum, and after this I'll return my answer. I need to save time. And after being visited, so this is some kind of redundant code which can be reduced. Visited uh, minus minus, because every time we are visiting, even if it is there, even if it is not there, but travel cost each time we are having a travel cost, so this condition will also be viable over here. No, this is wrong. This is totally wrong. No. What? This is so small. In this problem we get to know a different variety of DFS with a stopping condition of time rather than all visited. We have a variable called time which is going maximum time. I need to have something in the parameter and something in my if I'm visiting it the first time, I'm adding it in my score, visited plus plus. If node is 0, answer will be maximum of answer comma score. So this is like direct DFS. We are no memoization, no return type, simple void null, bro. Okay. So this is so blunt type of thing. Now, if I have visited that node, uh, keep a result and current sum. If I've already visited it, and if it is a uh, I will not return in this case. If node is 0, uh, I in any case I will not return. If I have already visited, that node is already visited, and if not, then a node then my result will be maximum of result comma current sum. I don't need answer. I will travel its adjacency list. I will visit this new node. Even I'll visit this current node. So I can add over here like visited. I visited this current node, and when I'm falling back, I'm telling that I did not visit this current node. Okay. Now new node and travel cost. Result is passed by reference. Current sum will be variable, and I need one more thing, that is I have this time variable, I have this answer variable global. Where is this answer variable? 2, 3, 4. There are total of 4. 1, 2, 3, and 4. So I have 1, 2, 3, and I need time also. If time is greater than my max time, I'll simply return from here. Time is greater than my max time, I'll return. I'll make that node visited over here after this. And visited of this node is there, and its node, and that node is 0, so we'll count it. And I'll simply call my DFS. DFS will be node, new node. Now this new node, if this new node is visited once, I'll have to add it in my current sum. Now if visited of new node is equals to 0, that means it is first time it is being visited. Then I'll do a DFS call of this new node adjacency list visited max time will go as it is, values will go as it is, result will go as it is, current sum will be added with values of new node, and time will be added with and this time there will be no value added overall. And nothing to return. Nearly the first. Oh, nearly the- Okay, sorry. Mhm. 20. Why 20? What wrong I did? If time is greater than max time, that's what I did. If time is greater than max time, I returned. Visited of node is 0. Score plus score. We visited it for the first time. Okay, I did not add the cost of 0. So my current sum will always contain values of 0. Where is the stopping condition? This is the stopping condition that we are talking about. This is the stopping condition that we are actually talking about. Okay, so now it's fine. So this was something related to uh, DFS. We could have also solved it using BFS. I think BFS would have been easier side for this, because if we are going for BFS, we know max time. We'll have to keep all those variables in vectors, q of vector, and we will do it. Yes. Both is fine. DFS is also fine, and BFS is also fine. So the way I approach to this is more of a sophisticated one. Okay, fine. Okay, so these question needs revise always. So I will be copying this solution. Uh, Journey to the moon. I need journey to the moon and maximum path. I haven't created. This is the DFS. Uh, DFS with stopping condition.cp. Actually, this is same as that. Okay, where is the link? Journey to the moon only. Journey to the moon has had no stopping condition. Um, they were flowing directly, but we can create a stopping condition in that case also. Uh, so the next question is connected components. And this reconstruction itinerary. Uh, okay. Traversal and connected components. Okay, this is a good question. Connected. Uh, so next we will be going with this. I want to complete this till here today. At least cycle detection. Okay. Oh my God. There are lots of questions in cycle detection. Topological sort also. MST, DSU, Dijkstra. These two has lots of questions. Cycle detection and topological, because they are important. Let's try as much as possible. Let's not stop here. Okay, 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 no problem. I'll be back in 10 minutes, and then we'll start again. Back in 10 minutes. Okay, back again. Let's do it. So now we are left with two more questions. I want these two questions to finish in this session, any at any cost. I really want it badly. So let's see. The next question is couples holding hands. Let's understand the question. There are n couples sitting in two n seats arranged in a row and wants to hold hands. The people and seats are represented by an integer array row, where row I is the ID of the person sitting in the ith seat. The couples are numbered in order. The first couple being 0 1, the second couple being 2 3, and so on with the last couple being 2n minus 2, 2n minus 1. Return the minimum number of swaps so that every couple is sitting side by side. A swap consists of choosing any two people and then they stand up and switch seats. We only need to swap the seats row. So I need to make 0 1 and 2 3 together, right? Currently 0 2 and 1 3 are together. So 3 2 0 1. All couples are already seated by side. 3 2. Okay, 2 3 or 3 2, say 0 1 or 1 0. So I need to arrange it in sorted order, right? And not in sorted order, not exactly in sorted order, but in some specific order. So it might have been the case like 1 2 0 3. So if we swap, we'll get 1 0 2 3, and it's fine. It's fine. They are sitting. The couples are sitting together. 0 1, say 0 1 or 1 0. It's fine. Now, how to approach to this question? All the couples are already seated side by side. Zero to two, two to one, one to three. One to two, two to zero, zero to three. 1 to 0, 0 to 2. Okay. So any insights of how to approach to this question? I need 0 connected with 1, 1 connected with 0. I need 2 connected with 3, 3 connected with 2. Let's see. And then we just need to form components. Let's say one partner is present in node A and another is in node B, then join them. Node number is I by 2. Then let's say a component has n nodes, and then swapping will be, by the way, only these n nodes, hence n minus 1 swapping. So do the same for all components, or it's his under based on his understanding, but this is not based on my understanding. What did I do? I need some insights. Let's try and understand with. Hmm. This is just a swap method. And how he did. So this couple holding hands is something good. Let's see. Row. I have unordered map of integer map. I'll iterate through this map of row is equals to I map of row is equals to I. Now I need to know iterate over the array is lesser than row dot size and I plus will be 2. I'll increase the iterator with 2 and not with 1. Okay, now then what we can do is we simply need to check whether this value is next value is like first and second, first partner and second partner, something like that. So my first partner is a row of I, and second partner will be based on the condition if uh, first partner is even, then is even, then plus 1 is even than 1 or minus 1. Correct. If it is odd, then it will be 0. If it is even, then it will be plus 1. So we found the first partner. Now if the second partner, if row of I plus 1 is not equals to second partner, that means we need something. So swaps will be plus plus, and I need to swap values as well as things from map also. So what I will do in this swap method, I'll pass I plus 1, that value needs to swap with this and swap it with map of second. Map of second will give me an index. That index needs to be swapped with this index in this row. let's quickly write the swap method. I can make it a private method. So swap is nothing. I need that map also with me. I need first, I need second, vector ampersand row, and an ordered map. Now inside my temp I'll keep the first value, row of first, now row of second, row of second, no, row of first, row of second. I'm getting confused in this, and now row of second will be, I need to swap it with my map also, so uh, first value has been first value has been taken inside this temp. Now map of this temp, now this is swapping at the second position, so its index will be this, and now map of row of second is equals to first position. Sorry, row of I is equals to I. For 0 it was even, I got 1. 0 we wanted 1 for just a second. Why? For 0 we wanted 1, for 2 we wanted so here now it is 2. For 2 I need 3. I will write comment connected components. I don't know this is connected components or even not. Connected components has better examples than this. Just iterate over the array and find its next couple. Just a minute. Hello. Sorry, I got a call from my father. So where were we? We were writing comment. So if the tuple is even, then next will be odd, and vice versa. If the next next if the current partner, the next partner is not in its position, then swaps will increase, and the VAL values will be swapped both in array as well as map index. Okay, let's go to the next question. Is reconstruction itinerary. You're given a list of airline tickets where ticket size from I to I represent the departure and arrival of airports of one flight. Reconstruct the itinerary in order and return it. All of the tickets yo, arre, belong to man who departs from JFK. Thus, the itinerary must begin with JFK. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order and read as a single string. The itinerary must begin with JFK. Okay, I didn't get it. Let's go back again. Let's go back again. You are given of airline tickets. I have been given a airline tickets. Fine. From to two represent the departure and arrival of airports of one flight. Departure and arrival airports of one flight. Okay. From here it'll departure. It'll arrive here. Okay. Reconstruct the itinerary in order and return it. All of the tickets belong to a man who departs from JFK. Thus, the itinerary must begin with JFK. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order and order when read as a single string. For example, the itinerary JFK LGA has the smallest lexical order. JFK LGP. Come on, why so complex? Hello. Thank you. I'm late. I know that. I know that. But what to do? Okay. So this question, I need to solve this question at any cost. I have to. So reconstruct itinerary is nothing but a type of multiset where what we are doing, we are inserting values in our multiset. Because we can insert multiple same values in multiset, so it's possible. So we started a DFS, started with JFK answer, reverse answer dot begin, answer dot end. So we started this JFK with my multiset and answer as empty. Now in DFS, what we are doing is we created a string. Now we need a path to go, right? A path to form. From here, where I can go, m of node uh, will store everything in temp. It's okay. It's nothing but iterating over the multiset. So I stored it in temp. I iterated over this multiset. I checked in my map whether m of known dot find a is not equal to that it is present or not. Like from here I can go here. From here I'm going here. From here I can go somewhere or not. So if m of node dot erase m of node find a. Okay, now this question we just have to keep moving the edges one by one. Better to use multiset. So it's very simple, right? We just have to reconstruct the itinerary. We just have to follow from JFK to ATL. We go back to JFK and we do not go back to ATL again. So if JFK to ATL and ATL to JFK, JFK is finished. Now there is no JFK present. So this multiset uh, is helping me. So, so what exactly is happening is this JFK, our itinerary is something like that. From JFK I can go to ATL. From ATL I can get to JFK. From JFK I can go to SFO. From SFO I can go to ATL. From ATL I can go to SFO. From ATL I can go to SFO. So this is what I have. So from JFK to ATL, ATL back to JFK. Uh, and at last when I'm returning back, I'm pushing these nodes from back. M of node dot erase JFK or dot ATL. Find ATL is present, so I'm erasing ATL from here. That I will not go this to this ATL again. Might be from JFK we go to two times ATL, so it's possible. So that's why it is. We are not going to ATL again. From ATL we went to JFK. So we have JFK. Will not go to JFK again because this is the second time I'm going. So from JFK I cannot go to ATL now because I have already went. From JFK I can go to SFO. So it's a map. So this will be in sorted order, and this is a multi-set. Sorry, this is a multi-set. Multi-set will always make it in smaller to bigger. Got it. Got it. Got it. What this multi-set is, map will make it in no multi-set will also keep it in ascending order. Map of dot insert string A is tickets of I of 0, string B is nothing, tickets of I of 1. So if we are, there are multiple ways if we can go. In that case, using multiset will always help me. If there are multiple arrows going here and there, multiset is going to help me a lot. Map tickets of I insert map of A insert B. Okay, so multiset is created. Now I need instead of having a DFS, we just need to iterate. Just do DFS. So DFS iteration is simple. This map will be passed starting with JFK. This map will be passed and I need an answer and I'll return this answer. So this void DFS is nothing, it will take this map and multi-set ampersand map and vector int answer. So this is not answer, this is sorry, not integer, this is string. And there is one more parameter. Now I'll iterate over them. So I temporary vector I will take temp is equals to map of node. Can we can direct iterate na? Okay, that's why it took, because we are erasing. Erasing will create a problem. Right, right. That's why he took something like that. So for string str of map of node, auto str of temp if map dot find str is not equals to map dot end, that means this str is there in my map. So map of node, sorry, so I'll have to erase map of node dot erase map of node of str. DFS with this str map and answer. Why we are pushing it in? Reverse answer dot there should be some problem with erase operation, right? Knew that. M of node dot find a. M of node why map of node, why here map of node dot find str. Why map of node? Why this happened? Why we are checking this value is present inside this only? I got this temp. Thank you. नहीं बस बस.
Consumer.
Why this map of node? I took all the temp value. I started this ATL. I removed this ATL. Fine. Next is temp. Why this will not work? Why? From JFK we went to ATL. We're checking the same thing. Map of JFK dot find this ATL. So map of JFK erase map of find str this ATL, remove this ATL. I removed this ATL. ATL called JFK again. I removed this JFK. This JFK has SFO. Called this SFO. I removed this SFO. SFO called ATL again. So this ATL, I removed this ATL. Now this ATL has SFO. Now this ATL has SFO. What? JFK passed this ATL. I have this ATL. I removed this ATL from here. I went to ATL. I found JFK. I removed this JFK. I went to JFK. I have this SFO. I removed this SFO. When I came back, I found this SFO in my temp, but not in my map. SFO पेपर SFO नहीं मिलेगा मैप में. क्यों नहीं मिलेगा? क्योंकि वो ऑलरेडी इटरेटेड है पहले से. दैट इज़ द रीज़न वी वोंट बी एबल टू फाइंड इट. करेक्ट. ओके. Reconstruct. We keep multi-set here. We keep a multi-set. We keep a multi-set which will value both map and multi-set are sorted. Need to iterate over the yes, and once we iterate and then see this again. Okay. I think I'll stop here today. I don't want to, but I have to. So I was only able to complete this BFS and DFS part today. So tomorrow I'll try cycle detection, topological, MST, DSU, sort test path, strongly. Let's see how much can we go. I don't know, but let's try our best. Let's give our best. Let's see. I think graph part is the hardest part of all, and the DP. I think after that it will be a little over the easier side. I'll keep revising these things again and again as much as I can, so that I should not forget it. So I'll stop here today. We'll be back tomorrow same day, same time, hopefully, and we'll we'll continue the our work. So thank you guys for joining in. I really appreciate your time and effort. Love you all, and see you on next stream. We'll be back. Thank you. Bye bye.